So, everybody, welcome to the June edition of the Astro Anglo-Irish Geeks. Someone of us always messes up on that one, which also was out on astronomy.fm. Through the show, we have quite an interesting guest always in, but the conversation always on our shows goes to planetary defense, planetary science, asteroids, comets. On the March show, we had Dr. Kelly Fast. So it was inevitable that we were going to have a June feature for Asteroid Day. Today, so we're joined with Danica Remy, the president of the B612 Foundation and co-founder of Asteroid Day, and Joachim Moeyens, who is the co-creator of Thor and a fellow of the Asteroid Institute. Thank you so much for joining us. It's such an honor and privilege for us to get you on the show, and you're very welcome.
We're delighted to be here.
Yeah, thank you.
So just to start off, Danica, with yourself, the B612 Foundation, and a little nice way to bring it in, this book, The Little Prince. Just to give a synopsis of the book, we first learned about this book, it was through Asteroid Day a few years ago. So I bought many copies, so many of our space friends around the world has a copy, because it's just a brilliant little story. But The Little Prince is a classic tale of equal appeal to children and adults. On one level, it is a story of an airman's discovery in a desert of a small boy from another planet. The Little Prince of the title and his stories of intergalactic travel. Now with the B612 Foundation, there is a reference to the asteroid. So what is the connection, Danica, with the B612 Foundation and how this book inspired?
So I run an organization that's dedicated to protecting the planet from asteroid impacts. And when the organization was first founded by a couple of astronauts and astrophysicists, they were sitting around a dining room table in Houston, trying to think of the name, what they should name the organization that they needed to found to publish some research papers. And one of them said, "What was the name of that asteroid that the little prince lived on?" And then one of the other ones said, "You know, there's this thing called Wikipedia. Let me look it up." And there it was. The answer is the asteroid that the little prince lived on is B612. And so that's how our organization's name was created.
It's an incredible story, you know, and how from a book for adults and children, how it intersects and, you know, how it crosses over and how an amazing organization was born. And for yourself, Joachim, you are the co-creator of Thor and a fellow of the Asteroid Institute. So what is that role and what is Thor all about?
Yeah, sure. So I'm a grad student at the University of Washington, and the donors to the B612 Foundation helped create the Asteroid Institute. And the Asteroid Institute is funding the remainder of my PhD. So working on graduating this summer, but I'm essentially here because of the small donors that the B612 Foundation has been able to secure funding from. And part of my kind of PhD thesis work has been the development of this algorithm called Thor. And to put it just really briefly, Thor is an asteroid discovery algorithm that you run on data sets from telescopes. And the input is the data set, the output is a potential discovery of an asteroid. And what we're doing now with the help of the Astro Institute is actually kind of building up that discovery algorithm into like a service provided to the community, where you can imagine having, you know, the eyes on the sky, the telescopes are operating around the world. Our goal is to get all those observations in and run Thor on them to be able to then discover asteroids and get those out to the community.
Part of that, go ahead, Nick.
Sorry, Carol. Well, one quick question I have. How user-friendly is Thor for, say, the citizen scientist who wants to get involved?
That's a great question. And we still have a lot of work to do on that, right? So at the moment, the user base for Thor is just one person, and that's me. we're still kind of in the kind of developmental phase. We have the ability to essentially scale up to using thousands of computing cores on Google Cloud. But the know-how right now kind of rests on only a few people in the Asteroid Institute. What we're actually working on this summer is kind of changing that. And that means so that, you could come along and say, hey, here's my observations from my telescope that I built in my backyard. Let's see if we can discover asteroids. And so that's kind of our ultimate goal, but we're still, I would say probably a year from that being reality. So there's still more work to do on our end to get to that stage.
Yeah, and for us as an organization, our priority really is to get these tools up and running for the internal core team. We're working to be ready and able to take in the data that's going to come from the Vera Rubin Observatory, what's called the LSST data set, into ATOM so that we can do a rapid analysis as to whether or not any of the asteroids that Vera Rubin finds might have our address on it. So we're very focused on that, getting that done first. And then we'll start thinking about how we can slowly expose some of the services that we're developing for other scientists or for the general public.
With Thor and Adam, I'm going to have a go at, given the abbreviations of these Thors, trackless heliocentric orbit recovery, and Adam, asteroid discovery, analysis, and mapping. So what is the difference with these two, and what exactly are their jobs, and how do they intersect with your mapping and finding of asteroids? How does the two of them work? Do they work hand in hand? Is it two separate?
Yeah, I think I can start there. So ATOM, the Asteroid Discovery Analysis and Mapping Platform, is effectively an astrodynamics kind of platform where scientists can come along. They say they have a very complicated, computationally intensive question they want to have answered. They can use that platform, the tools that it provides to try to answer that question. And Thor now kind of lives in the umbrella of that platform. So the D in ATOM is discovery. The discovery algorithm is Thor. And so what we're trying to do with Thor is to effectively provide the means or a discovery service as part of the ATOM platform. And one of the amazing things about this is that Thor is a computationally very intensive algorithm. And so ATOM is kind of the natural home for that because it has access to, we can spin up thousands of cores to churn out asteroid discoveries.
With the other space industries, with the current searching of asteroids, with NASA, ESA, the different, all the time looking for asteroids. With your project being accredited with the Minor Planet Center, these are actually one of a major player now in this as well. So to date, how many have you calculated?
Yeah, so a couple of weeks ago we had that announcement of 104 discoveries, and so 104 sounds cool, but people discover asteroids every day, and so 104 is actually kind of a small number. But for us, it wasn't the number that's actually meaningful. It's the fact that it validated our approach. And so Thor, the discovery algorithm itself, is unique in that it allows you to discover asteroids in data sets that were not built for asteroid discovery searches. And so that effectively has made all of the astronomical data sets in the world right now a data set where we can now start looking for asteroids. And so building up to that kind of milestone for us has been really validating that our technique works. And so we analyzed a small fraction, like less than 1% of this vast data set, and pulled out 104 discoveries. What we're working now actually over the summer is to get the entire data set kind of pushed through, and we think that we could discover tens of thousands of new asteroids in this data set. And so right now we have 104, but it's really just the beginning of something much larger. And to us, what it comes down to is it validates that this algorithm actually works. And so that's why we were also excited about it over the last few weeks.
Yeah, and just a clarification, these asteroids that Joachim's algorithm has found are main belt asteroids. So Joachim, do you want to just say a little bit more about what you and the team are going to be doing to go to the next step?
Yeah, sure. So yeah, completely correct. So these are all main belt asteroids. the way that we developed Thor was we always had the use case of the Very C. Rubin Observatory in mind. And the vast majority of the discoveries that telescope's going to make are going to be main-belt asteroids and outwards. And so we figured when we were developing a new complex algorithm, we wanted to first address the use case that's going to be most common, which is discovering main-belt asteroids. But what we're working on now is actually extending it to the NEO, the near Earth object population. There's nothing from the physics standpoint that's going to make that not possible. Like I'm convinced we're going to be able to discover NEOs. The reason we haven't done it yet is A, I just haven't had the time, but B, we needed more compute power. Because they move so much faster, the way the algorithm works, you just need more compute. And that's compute that's readily available on Google Cloud. So this summer, we have a bunch of undergraduate students that we're working with who are going to be start importing a bunch of new data sets. And then we're going to simultaneously start working on really seeing if we can start discovering the near Earth objects. And that's going to be super exciting because we're going to be using even more compute power on Google. So,
yeah, that's a really important aspect to the work that we're doing has been the strategic support that we receive from the Google Cloud team. And we're doing really cutting edge computational work. And it requires having the latest kind of computational tools. And so this public-private partnership that we put together with Google Cloud and B612 is really quite unique. And our goal, of course, is to make this readily available to larger and larger sets of users over time. But we're starting with our priority, right? Which is let's get the software working for the asteroid discovery, both far and near. And be ready for the LSST data feed. And then we'll start thinking about what we can easily expose the services to the public.
And with this as well, it's fascinating, what you've discovered so far, in your work and what you do. I know that you're, a non-profit, it's a private organization, but with your findings, with risk lists, with asteroids, what's known, the unknown, how will that develop into then with, obviously with the Minor Planet Center, with the different agencies? We have up and coming asteroid missions, currently missions in orbit. Let's say like the James Webb Telescope going back in time, how then will your work, with funding, will you be able to link in with that to be part, with the discoveries and doing the science on other industry missions as well?
Before Joachim answers that question, I will say that, of course, we are a charity. We require, need the support of the general public. Anyone who likes what they're hearing, of course, can go to b612foundation.org and make a gift. And a lot of this is simply a matter of funding. With the right amount of funding, we'll be able to build a lot of things. And this area of asteroid science is a pretty narrow niche in the world of astronomy, and then in the world of all problem sets that exist that we have to get done as human beings. So we rely on support to be able to enable, fantastic scientists like Joachim and the rest of the team that's coming up with him and around him. So over to you, Joachim, to talk about how we work in an ecosystem of other players.
Yeah, so right off the bat, so all asteroid discovery is going to be complementary, right? Like we need more eyes on the sky to discover more asteroids. We want to know what's out there. There's no harm in doing that, right? That's one of our ultimate goals. The way that I see kind of the Asteroid Institute play a part in this with the Atom platform and with kind of Thor in that ecosystem is, we built this algorithm. It's able to discover asteroids. Today, if you want to discover asteroids, you typically have to build in-house software. So telescopic surveys, professional astronomers, they are writing code to get these discoveries out. And one of the kind of the long-term visions that we have is to kind of centralize that discovery effort, where you can imagine, say that you have assets from Europe or assets in North America, wherever they are on the globe. These telescopes are making observations. And if you imagine just building this kind of central hub where those telescopic observations can be sent to and then analyzed for asteroid discovery, all with a single bit of code that's well tested, well developed and kind of open source and available to the community. That's kind of the larger vision that I think we have in mind, is that we want to be able to centralize that discovery effort. And that's a complementary service that we can provide, right? And so, you know, it costs millions of dollars to build these kinds of discovery algorithms. Having each individual telescope build their own in-house for this kind of purpose-built telescope might not always be the optimal solution here. And I think where the B612 Foundation and the Asteroid Institute can play a part is centralizing that effort and providing a really useful tool to the community. And one of the things that I often find myself, what I need to remind myself of is that, like, this algorithm really works well in that it allows you to discover asteroids in archival data sets that already exist too. And so we're just effectively, it's still the same data set, it's just a different approach, and somehow we're able to pull out discoveries. And I think just making sure that we focus on doing that while also providing that service to the community at large, I think that's kind of the ecosystem that we're trying to build. And again, as I said earlier, it's complementary. Like, we're just trying to figure out what's out there. So, yeah.
As you say, you know, more eyes on the sky, and then, you know, with the asteroid belt, you know, millions of them undiscovered, you know, the bigger ones, the smaller ones, and they're unpredictable, you know, so that's the importance of always, for yourselves with mapping. And obviously I'll mention again, it's the brilliant organization with the funding. But just to go back a little bit, what got you interested? Why asteroids?
Well, so for me personally, I was an undergraduate at the University of Washington, and a friend of mine said, hey, we need to take some elective classes. Let's do an astronomy class. And so I took the astronomy class. So to preface this, I've always been interested in space. I was trying to be an aerospace engineer. It didn't work out. It's okay, I'm here now. This is much better. So yeah, we were taking this class, and the professor who was teaching that class is now the director of the Vera C. Rubin Observatory. And he ended off that class by saying, hey, we have so many research projects that we need done. We do not have enough students. If you're interested in doing some research with me, send me an email. And so I went home for the summer, thought about it for a bit, sent him an email, and he came prepared with a list of 4 different projects to work on. We started on one, we kind of worked our way down. And now I'm in graduate school working on my PhD, working on asteroid science. That was all just kind of a consequence of just taking a single class and just kind of sticking with it and doing like complicated research problems. Yeah.
If you had to find a way to enthuse the general public and stress the importance of Asteroid Day, how would you both do that?
Danica, do you want to go first?
Sure. I mean, I think that I didn't know anything about asteroids before I started this job at B612 Foundation 8 years ago. I knew a little bit because I was friends and colleague with one of the co-founders, Rusty Schweikart, who's a Apollo 9 astronaut. He and Dr. Ed Lewis started B612 Foundation. And the thing that really is important about the public education program, public awareness education program that we started called Asteroid Day is that, you know, asteroids are really interesting celestial objects. I mean, they brought me the water that's in my glass. They're going to be interesting celestial objects for us to go visit. We're going to learn a lot of things from the missions that are bringing back samples. They are going to be useful for, you know, in the future, space resources utilization, water being sort of the primary first starting place. And then finally, you know, occasionally they hit our home planet. And so when we started Asteroid Day, really, we started with a very simple call to action, and a lot of really fabulous scientists and business people and, you know, celebrities, whatever, signed up. And it's very simple. Let's accelerate the rate of asteroid discovery by 100x. That's our goal. Do it by funding universities, funding organizations, by funding scientists, by encouraging, you know, astronomy clubs to you know, look for asteroids. And so, you know, we think asteroids are a pretty exciting subject. I mean, astronomy is big, space is huge, the universe is even larger. So we have a little vertical, it's called asteroids. We're all about asteroids. And we want people all around the world to be inspired. And when we created Asteroid Day, we modeled it after Earth Day. So nobody owns Earth Day. Nobody owns the environmental movement. The world came together actually to create the environmental movement. And so Asteroid Day has thousands of independently organized events that have happened all around the world. And they're organized by schools and universities and science clubs and governments. And that's what we want. We want people to be inspired by asteroids. I'm inspired by them. I didn't know that much about them 8 years ago, but I think they are just absolutely amazing storytelling tools. They're going to tell us how we got here, how Earth was formed. It's good. They're going to help us. I don't want to leave my home planet, but other people do. Those explorers are going to need the resources on those celestial objects. So, Asteroid Day is about inspiring people to think about whatever aspect of asteroids or space inspires them. And so we have, hundreds of tools and learn modules and videos, and we invite scientists and experts to talk about asteroids so that we can educate the world about all things asteroids.
It's incredible, Danica, as well. With Asteroid Day, we're very passionate about it. Right now, us doing the show, all around the world, there's events happening. There's lectures going on. There's kids in school, making comments, talking about asteroids, preparing, doing art, maybe music and dance. There's everything is intersected into it. And just to think, we're sitting here now, and all around the world, there's an event happening. But just for, the listeners, the Asteroid Day, June 30th, 1908, the Tunguska explosion, flattened 830 square miles of a Siberian forest. Then the UN declared Asteroid Day was an official day to inspire and educate the world about the wonders and dangers of space. And as you say, it holds pieces, jigsaw pieces and clues to, where we come from, and the importance that I love when you talk about, Danica, with, the Water and Earth Day, especially, with the signatories involved with Asteroid Day, the fascinating, people like yourself, Joachim, in the work you're doing, astronomers, scientists, amateur astronomers, the celebrities on board, the astronauts, and especially from their perspective, they've seen our planet. Some of them maybe have been in space once, they've been on a few missions, and on their time, they can see the differences as well as all the other world crisis that's going on. There's no borders in space, but with asteroids, the potential, it's not a case of if, it's a case of when. And with the climate change going on, you mix in then the potential impact of an asteroid, and those stories are important. And, to people to keep seeing how beautiful our planet actually is, and the importance of, protecting it. We've been over to Asteroid Day. It's an incredible place, the people that are involved in it, inspiring. It's just incredible for the future generations as well.
Well, we've been so happy to have you join us there, and one of the really critical elements that you just called out there is that, in fact, Asteroid Day wouldn't be here today if it wasn't for what a group called the Association of Space Explorers. So the ASE, Association of Space Explorers, is the club of people who've been to space. So there's about 560 of them who qualify to be members of the Association of Space Explorers. And almost 20 years ago, Rusty Schweikert, who also was the co-founder of B612, worked with the ASE to start a committee at the United Nations level to start looking at this question about asteroids and planetary defense and risk mitigation from asteroids. And so the ASE had, really invested quite a bit at the global level, at the UN level, talking about this question of, what is the planetary risk from an asteroid impact and what were the options that we would have from a technological or scientific perspective. And then finally, what are going to be the geopolitical barriers? Well, we know that, and we will know one will be heading towards us at some time in the future. So humanity will be faced with this challenge. And so the Association of Space Explorers are really quite critical in starting that global conversation at, the body that's actually going to be part of the discussion about what are we going to do. And so when we created Asteroid Day after the Chelyabinsk asteroid explosion in 2013, the ASE was the group that actually took 2 years later the resolution to the United Nations to create Asteroid Day as a UN day recognized day of education and awareness. And they were able to do that because they'd already started the conversation. So these space travelers who've looked at our home planet without any borders, with all of its fragility from space, knew that they needed to do something to begin the conversation about how do we protect our home planet. And so, 4 of us are credited with founding Asteroid Day, but really it was the collective of the Association of Space Explorers.
I have to admit, from my perspective, it was Shoemaker Levy 9 that got me interested in Asteroid Day. I think for a lot of my friends, again, we're seeing it from the comet perspective, and of course, we all remember the Hollywood attempt. I still think the only decent one was Meteor with Sean Connery today, but that's just my point of view. But I think that's one of the things that's perhaps also got a lot of people interested in Asteroid Day, is because they've seen Hollywood do its bit, and now they can hear from the real experts about what really we can do to mitigate any potential problems. And perhaps it's a bit hit and miss with the Hollywood angle, but has it helped at all?
Well, they're good to make a joke about, because none of them are really scientifically correct. Although when I talk to people who know their way around the science, they say deep impact was the closest one to being scientifically correct. I think that they are helpful in raising awareness. Don't look up, which we've all probably talked about at one point or another in the last year, was really developed to start a global conversation about climate. And in fact, the reason why they had a comet instead of an asteroid as the protagonist in that story is that when an asteroid hits our home planet, maybe we're going to see it for the last 4 or 5 seconds and a vapor cloud behind it. But because the whole gist of that story was really about denial of science, they needed to have a data point. So a comet is a much better data point to have hanging in the sky because it's there for many, many days. So if the politicians are saying, no, there's no comet, the Earth is not, there's no risk, 60% chance. Once the public sees the data point hanging in the sky, it becomes a different conversation. So that's, that data point, that transparent data point is one of the reasons why it's so important for us and what we're building, and Joachim and the rest of the team are building, is that these algorithms are open and transparent. What Joachim has written, anybody can read. And anybody who wants to figure out whether or not it's true that asteroid is there in the sky where, his algorithm said, or, it was, can go verify it. That kind of independent verification is really quite critical. And so when we talk about, what the challenges might be in the future, when we know that an asteroid is on its way towards us or as a risk, other people ought to be able to really quickly verify whether or not they believe that or not. And so they were not able to do that, of course, in Don't Look Up. But we will be able to do that in the future because of the things that Joachim and the rest of the team are building.
Just going back, Danica, as well to 2019, when we were over in Luxembourg for Asteroid Day, we were sitting on the technical briefing, and just 2 days prior to that, it was announced that a car-sized asteroid came in, exploded into 3 parts, and landed, luckily, in the Pacific Ocean. So it just shows you how importance of Asteroid Day, you know, with the education, you know, what's known about the unknown, there's the evidence. And, you know, with the work you're doing, what you're finding, it's like, again, we can't say it enough, not a case of if, when, and they are unpredictable, and they're 2019, sitting for Asteroid Day preparing, it happened, luckily, and into the Pacific Ocean.
Well, we're so grateful to the public education work that you and Hayden have been doing over the years, and we're, you know, so delighted to have Hayden as our Asteroid Day ambassador.
When I was 7 years old, Professor Alan Fitzsimmons placed a piece of the Chelyabinsk meteorite in my hand. From then, I was fascinated by the wonders and dangers of space. I'm now a planetary defender. It means so much to me being ambassador for Hera mission and Asteroid Day. Me and the other kids are the future of space and science exploration.
We are so thrilled to have you be part of the team, Hayden.
Yeah. It's incredible to imagine, you know, the future. Alan Fitzsimmons piecing that little tiny piece of the Chelyabinsk in Hayden's hand, and it's totally inspired. And I didn't know an awful lot about asteroids either, you know, doing other space reporting stuff, and it's now a big passion in this house, isn't it?
Well, it's funny where you find your passion, because I would have never imagined in my wildest dreams when I was young that I would be working with a bunch of fabulous scientists like Joachim and Mario and all the folks in Europe and across the world talking about asteroids. You know, you just never know where inspiration is going to take you, and you never know what you've learned, how it can be valuable for a group of people or an industry or a sector that you never thought of. And that's sort of part of the winding road of one's life and one's career, is you just never know when a professor says, send me an email, like Jelko did for Joachim, you know, where it's going to lead you. And I think one of the important things is that, you know, you should just always try and remember that, you know, there's always someone that can teach you, and there's always someone that you can learn from. And in doing that, you should be open to being both a teacher and a learner, and to follow a road that might not make sense, because it could take you somewhere really, really interesting.
Yeah, I have to agree with that. I started out with wanting to do basically an astronomy degree, and now I'm going into planetary sciences. So yeah, you're quite right with that.
So with the Asteroid Day, Danica and Joachim, you know, with your work with the B612 Foundation and the Asteroid Institute, what is your hopes and plans for the future? Obviously, you know, finding more asteroids, protecting Earth, getting them catalogued. But what would you like to see more for the future? You know, more funding, obviously, into the exploration of asteroids. And there was an astronaut that said to Hayden quite a few years ago, you know, you remove the "im" from impossible, anything is possible. And that was actually Paolo Nespoli when he met Hayden, and that has stuck, you know, ever since. Hayden has this dream about, he's disappeared again. He's a short visitor. One day, you know, the future could be possible to be part of a crew, maybe going to an asteroid. Hayden brings this up when things we were on, and you kind of gets a gasp and a jaw drop. We're like, whoa, going to an asteroid, we're not there yet. But it's the inspiration, the imagination, the hard work that, anything can be possible with the teamwork and obviously the technology. So what would be your thoughts on that?
Yeah, so I think for me, so for asteroids in general, so I mean, I grew up watching Star Trek. I would love to see that be actual reality. So like, space, especially the solar system itself, and exploring asteroids and what's out in our immediate neighborhood is kind of the frontier, right? And I think there's an innate piece of each and every one of us that likes to know what's out there and to explore. And so that's what I'm so excited about is, there's going to be a point in the future where we're going to know and be able to catalog most of everything that's in the solar system. And we'll be able to tell you, hey, this is a particular asteroid that could be interested to visit. This one might be, mineral rich or something, or this one might impact us in the future. And this is a problem that we have to solve today. And so, I think the first step to solving any problem is being aware of the problem, which is why Asteroid Day is so fantastic, is it raises that awareness. But one of the things for me is, like, you're definitely correct. It's like, these are low probability events, but eventually that probability reaches 100%. Like, this is something that a problem we're gonna have to solve in the future. And I think it's much easier to solve tomorrow's problems if you start working on the solution today. And to me, that's what this is just we're just doing our part to make sure that our civilization continues. And that, to me, I find super inspiring, and we all have our small role to play in that.
And I would say that journey to the day when we know one is coming is going to take us down an awful lot of roads. Awful lot of, new science, new tools, new technology, new exploration. I mean, all of that is as equally as important because it's driving innovation and knowledge and our ability to, problem solve together as a humankind. So the future we're working towards is going to be an exciting journey. Whether or not we see that future in our lifetime or not, it's just, we're on just a super exciting learning journey with people who come from different fields and different disciplines that are going to enable that future point of, hey, let's do something about, that asteroid, or, hey, we don't need to worry about it for the next 200 years. I mean, that might be one of the outcomes. So, it's about the journey of building and learning together.
Yeah, and I think the importance as well, you have the Planetary Defense Conference, which happens every couple of years, with the teams get together and they have a probable asteroid that, don't panic in the press, it's not real, but for them to put in practice, what measures to put in place. What time do they have? They're going to have to evacuate. How close is this going to be? How big it's going to be? And the importance of that, to always be ready. And as well, with the DART mission, we're coming up now to September. They're going to do the impactor. So that's fascinating. When that actually happens, and then with the working then NASA with the European Space Agency, the follow-up in Hera, of course it's important. People will say, why another mission to Mars? Why another mission to an asteroid? Because it's fascinating. We need to, find out more where we came from. As well, with the education side of it, you have these big press headlines. A giraffe size, half a giraffe size asteroid's going to hit Earth, the size of the Eiffel Tower. But
yeah, thank you, Rupert Murdoch. Thank you, Rupert Murdoch.
But what people actually do, they read they take the headline, and they're like, oh wow, and then they become immune to it. And every time, 9 times out of 10, we're always updating, sharing the importance of planetary defense. Read the thing in full, the education's important. Recently, whenever we had neowise visible to the eye, at least that was something that people could actually look at and go, wow, this is a comet, which is another probable things could hit as well asteroids. But the education is so important for people to read past the headline. We can't stress that enough.
Hey, Joachim, why don't you tell them about how many comets you found in your data sets? We're not just finding asteroids.
Yeah. So the way that Thor works, asteroids and comets are, from the physical standpoint, the same thing. So we have no problem recovering those. And in fact, when we ran it on one telescope, to kind of build the algorithm, there was a comet that we would have discovered had we been running real time. It's actually a parabolic comet, which is kind of interesting. But yeah.
Why is a parabolic comet interesting, since I know nothing about comets?
Because a parabolic comet is effectively right on the boundary of being contained within the solar system. If you just were to nudge it a little bit, it would technically be hyperbolic, and then it could leave. And the idea is that there's a very interesting mechanisms to get those comets in that particular kind of orbital configuration. But the cool thing about comets is there's very few of them. There's only about 4,000 that we know of, I think. And if you do discover one, you typically get to name it, which is always fun. So
that's great.
Maybe in the future, yeah.
And how many? What's the estimate for how many comets you think LSST is going to find over at Survey Life? You
that's
guys
a great
modeled that, right?
Yeah, we've modeled it. I don't know the exact number, but it should be on the order of thousands. So yeah, on the order of thousands. So I think we'll probably double the known population of comets with Vera C. Rubin Observatory. Yeah.
That's great. We have a couple of folks who are supporters of our work at B612, but they come from the comet side of the solar system, and so they're always saying, "What about comets? But what about comets?" And so I was so thrilled when when Thor ran and he had a couple comets in there. So I sent it off to these two folks. I said, "Hey, look, we're finding comets too. Are you happy now?"
Yeah, it's kind of funny for me. I just call them small bodies. So it's either asteroid or comet. I don't really make the distinction between them. I don't do that because from the dynamic standpoint, it doesn't really matter to me. But so it's always interesting that people like to delineate between the two. And we need to find those comets too. So
I know with the asteroids and comets, they have to go through the official channel to be named. People learning about asteroids, you'll see they follow with a number, they're catalogued with a reference. But do you have, with the ones that you've discovered, do you have any little names you've given them yourself?
Oh no, not yet. I think that's bad juju. I think, to start thinking, because so the whole naming thing is complicated, because if you discover something and you add it to the official catalog, it's actually not guaranteed that you get to name it. Because there, in some circumstances, a telescope might have observed that particular discovery before, but not observed it enough to where you would be able to make that discovery. Excuse me. And so the whole naming thing is a very complicated kind of esoteric process. But yeah, I haven't quite gone through and named the 104 individually yet. I know their provisional designations, but and there are some that I'm very interested in, that I find fascinating because of the way that we discover them. But yeah, they don't quite have names yet. Yeah.
Because I know with the different missions, when they map the asteroids, they have a theme, or they've come up with little different names named after people, just to kind of characterize and I suppose make it easier whenever you're looking. Oh, that's that bit. That's that bit. That's that bit. But future, would you like to, name parts of that when it comes to mapping of surfaces of asteroids?
So I don't really know. So Danica, maybe you can answer this question with regards to how the Asteroid Institute, because eventually we will have the right to name asteroids. But yeah, I don't think we figured out what we're going to do with those rights and how we're going to deal with the actual naming once we get to that. But
No, I think the challenge right now is that, and that what's exciting is that, you know, we've developed a new way to do discovery. I mean, we've discovered asteroids and we don't have a telescope, right? And so we're using somebody else's data sets to do the discovery. So we're treading on really new territory, both in the way in which we are finding them. And Joachim can talk a little bit more about why Thor is, you know, kind of exciting, why this trackless heliocentric object recovery algorithm is so uniquely different. So, you know, we're forging new territory. And so the answer to that question about naming rights is going to be a learning process for all of us, because nobody's done it this way before. So Joachim, you want to just talk a little bit about how it's, I don't think you did it at the beginning, did you, where you talked about how Thor is, the tool is, that its discovery is so different, not needing to have the 4 pairs.
yeah. So I mean, this is where like the whole discussion of Thor, like it's a mouthful, honestly, like the tracklets and all these weird concepts that scientists came up with to make things even more confusing than they need to be. But basically, the way that most telescopes discover asteroids is in a single image you take on the sky, you actually can't tell the difference between an asteroid and a star. So asteroid comes, literally means star-like. And so it's not until you get a second image taken typically within about an hour to 90 minutes from the first image, where you can imagine how blinking those two or flashing those two images, and you can actually see that asteroid move. And the process of building that kind of moving image and combining those two observations, that's actually called a tracklet. And for example, Pan-STARRS, which is a prolific discoveries program, what they actually aim to do is they try to get 4 observations of the same object in the same night. So they build a tracklet with 4 observations. And so that's state of the art today, is building these tracklets to be able to discover asteroids. Once you have that motion vector, like that direction, you can actually tell in the next night where it's going to be, or the previous night where it could have been, and that kind of helps you keep the computational cost of this kind of discovery technique down. Where Thor is completely unique in that there's no other algorithm like this, is we don't require you to come back to the same area of the sky in a single night. And instead, what Thor does, it looks for any 5 to 6 observations over the course of, say, a month, regardless of the spacing between those observations. And that's why it requires so much more compute power, is because it gets much more compute heavy to be able to solve that problem. And that's all like, you know, messy jargon for saying that this algorithm works on any data set. This is what it boils down to. Any data set. As long as you've observed an asteroid in that data set at least 6 times, Thor should be able to find it for you. And what's kind of amazing about that is that most astronomical data sets were never built to discover asteroids. Like, most people don't even really think about asteroids when you do astrophysical missions. They think of asteroids have been described as space vermin. They in the way of the real observations. And so where Thor kind of comes in is that we have all these data sets that already exist. We have future data sets that are going to be made. We can run the algorithm and discover asteroids that have been observed already, but just have not been actually discovered, or been pulled out from that data. And that's where, you know, we've been working on Thor for 5 years now. And so like the fact that these 104 discoveries were validated by the official clearinghouse for such discoveries kind of, it validates that algorithm, and now the door's open for us to go through and actually start making that 104 number a number that's in the tens of thousands instead. So
fascinating. We're just coming up on, we're almost out of time. We could talk to you guys for hours on this. There's so much to talk about, you know, the wonders and dangers of space. But, you know, a final message from just quickly from each of you. You know, you met Hayden there. You know, there's many other kids involved in STEM subjects, getting interested in space exploration, obviously, and planetary defense, and little scientists out there. But what would be your message for the future generations, and your hopes and aspirations in this field of importance?
I think maybe for me, I would just say be curious and be interested, and see where that takes you. There's so many different problems out there that need to be solved, and there's so many different ways to solve those problems. And I think each individual has the capability to bring some phenomenal talent and some new approaches to solving those problems. And I think just, if you're interested and it means something to you, just pursue that interest and see where it takes you. Because I think we talked about this earlier, life kind of flows. You just kind of see where things take you. And there's a lot of problems in research that get solved in that way too. Like you just start, you look at the problem for the first time, you try something, it might not work, but maybe in that process you learn something, and then you come up with an entirely new solution. And sometimes it works out that you create a new discovery algorithm, or you get to meet and work with all these fantastic people. And so, where there's curiosity, I think you just nurture it and keep going.
And I would echo what Joachim just said with a slight punctuation on the importance of all different kinds of brains to be applied to a problem. And so one of the things that I love about Asteroid Day that gets me all excited is when I see musicians who have, written songs for Asteroid Day, or chefs who have figured out how to do Asteroid Day cakes, or pizza pubs that have done asteroid pizzas, or brewing pubs that release Asteroid Day ale. That whole aspect of art and project management, and married to people who are hardcore science, technology, engineering, and mathematics people, that combination of many minds on a problem working together gives you really creative results. And so I often say to people when I'm talking about the work that we do at B612 and about Asteroid Day, is that there is an opportunity for all of you, every student, every child, to participate in a unique way that honors who they are as a unique individual. And I think Hayden is a great example of that. And every child that has done wild asteroid pictures in Chile and Brazil, and written songs and done dances in Africa as part of their Asteroid Day events, they are part of telling the story and educating the world about asteroids. And so remember that your creativity, however you have been gifted it, can be applied to something that you find interesting.
That's incredible, Danica. And Asteroid Day, obviously the live big day, you can check it out in all the social channels. And you just quickly, Danica, want to tell people how you can connect with the B612 Asteroid Day and tune into the live events?
Yeah, so B612 is at b612foundation.org. That's the letter B, the number 6, the number 1, the number 2, the word foundation.org. And if you want to learn more about asteroids and watch our live broadcast, which will be on June 30th, the anniversary of the asteroid impact in 1908, you can watch that at asteroidday.org. We'll have a live broadcast streaming on the 30th, and all year round, we have wonderful tools for teachers, for students, for learners, about everything from how to make an asteroid cake to how to characterize an asteroid, or how to fly to an asteroid. So I encourage the public to check out both of those URLs and join us for a happy Asteroid Day on June 30th.
I just want to thank you both very much for giving us your time today to do the show. And I look forward to next year.
Yeah, and thank you. It was a pleasure talking to you. Always fascinating. And keep looking up. And happy Asteroid Day.
Thanks for having us.
Yeah, thank you so much.
Hello everyone, Astronaut Hayden here. For this year's Asteroid Day, I wrote a children's story. Little Vesta, inspired by the little pieces of Vesta found on Bennu. I came up with a fun way to help inspire other children learning about asteroids. Little Vesta. Once upon a time, in a world far away, there was a crash, there was a bang, there was a wallop. Vesta, the asteroid, had a crash. Millions and millions of miles away in outer space, it was like a snowstorm. Whee! Cried the little voice, hurtling towards Jupiter, bouncing off Jupiter's red eye like a trampoline. Bounce, bounce, whee! The little voice was a fragment of Vesta. Little Vesta was in for a supersonic adventure. Flying through the atmosphere between Jupiter and Mars. Where am I going? Little Vesta yelled. Spinning and spinning. Whee! Getting pulled like a magnet and going from coolness to heat. Little Vesta noticed a beautiful blue line around the planet of blue and grey. Whoa! Little Vesta gasped. Coming from a cold, rocky place in space, Little Vesta became very warm. He noticed all of a sudden a beautiful golden orange ball around him. Flying towards the blue line, a planet of blue and green, 45,000 miles per hour. Little Vesta yelled, "Whoa! Whee!" Little Vesta, a part of a 4.5 billion-year-old asteroid, holds many clues. In a world far, far away where the solar system began, one day to be found on Earth to help you understand. Keep looking up for friendly visitors like Vesta. And one day, unexpected, you may find a piece of meteorite like Vesta.